Hey everyone, in this video we'll be learning about MergeSort. There are two important points to remember about MergeSort. Number one, MergeSort is based upon divide and conquer method. And number two, every time we keep dividing the array into smaller halves till the point where we reach a single element, and after reaching that we start merging the smaller arrays into larger array after sorting them. So every time we merge two arrays, we are actually merging two sorted arrays into one bigger sorted array. So let's see how it actually works. Now, as I said, we keep dividing the entire array into smaller halves. So we need one variable to keep track of that half, the half index from where we need to split the array. So mid variable is the one that will take care of the middle index from where we split the array into two parts. And in order to find the middle element, we need the first index of the array and the last index, which we would be representing by low and high variable. And in order to find the mid element, we do low plus high upon 2. There is another very good formula, there is another better formula that we use for finding the mid element. This formula can somehow lead to error when low and high have very higher value. I've explained this very well at the end of the video, so please do see at the end of the video what is the correct formula for finding the middle element. But this one also works, so we'll use this one for solving the rest of the question. So mid is equal to low plus high upon 2, and then we find the middle element, and based on that we split the array into two parts. So this is the array from where we start. The array is from 0 to 7. So we find the middle element, start plus 0 plus 7 upon 2, which is 3. So we split the element at 72. So we have two arrays now. So the element in the middle position would go to one of the arrays. So we'll move it to the first array. So we have the half the array as 18, 4, 172, and the rest half is 5, 56, 3, 7. For both of these, we'll further be dividing them. So there will be separate recursive calls for both the parts. So for this part, we further find the midpoint. The midpoint this time is 1. So we split at 4. So we have two more arrays, 18, 4 and 172. For both of them, again, we'll do recursive divide. So again, we find the mid element, which would be 0 plus 1 upon 2 equals to 0. So we again split at 18. So we'll have two arrays, 18, 4. This would be split to 172 and so on. So we have an entire array which is divided into smaller parts, which is equal to length of one element. Basically, we have divided the entire array into smaller arrays of one element each. Now our recursion for division stops here. Now we need to merge the array, and along with merging the array, we need to sort it. We split the array into smaller parts of one element each because we assume that single element is always sorted. So when we divide here, we assume that that is logically true. So these are already sorted. So we start merging them. Now for merging them, we see which one of them is smaller. So 4 is smaller, so 4 comes before. In this, 1 is smaller, so 1 comes before 72. 5 is smaller than 56, 3 is smaller than 7. So we have four sorted arrays of two elements each. Now again, these two would be merged. So this merging would happen recursively only. Like we had two recursive calls from here, then we had two recursive calls from here, then we had 4 recursive calls from here. So when this returns, this is the output that would come, and then for this one this would be the output, and for this it would be the output. So we won't have a combination like this, and this similarly this would give the result up. So now we'll be merging these two, 14, 18. So out of these we'll check which of the element is smaller. So 1 is smaller than 4, 1 comes first, then come 4, then 18, then 72. Similarly here, out of 5 and 3, 3 is smaller, so we move 3 here. Now 5 and 7, 5 is smaller, so we move 5 here. And then 7, then 56. merging these elements, we are actually maintaining different pointers to keep a track of how the sorting is taking place. So we'll have one pointer that will be pointing to the position of this the final merged array. There would be one pointer that would be keeping track of the elements in the first array, and there would be a second pointer that would be keeping track of the elements in the second array. So we'll see whether the element at ptr1 is smaller or ptr2 is smaller. If ptr1 is smaller, we move ptr1 element to the merged array, and then we increment only ptr1. ptr2 does not increment in that position, so we only increment the pointer whose element is smaller and whose element has been placed in the final merged array. So here ptr2 is smaller than 4, so we move ptr2, 3 is moved here, and ptr2 gets incremented. Again ptr2 moves here, and ptr1 is at 4. Now ptr1 is smaller, so ptr1 element, that is 4, would move to the final array and it would get incremented, and so on. So that is how we'll get our final merged array, and that is how merge sort is taking place. Now let's look at the time complexity of merge sort. The worst case time complexity and the best case time complexity both for merge sort is O of n log n. How? We see that every time we are actually dividing the array into two halves. So if we have n elements, every time we are dividing it into n by 2, n by 2, n by 4, n by 4, and we are doing it till the end we reach one element. So we, similar to this calculation I've already done in the video of quicksort, so you can go ahead and watch the quicksort video. I've very deeply explained how the time complexity of n log n is achieved. So similar concept is applied over here. Since we are dividing the array into two halves all the time, that the complexity that comes from there is log n, and then we start merging it, because of which it becomes n log n. So that is the time complexity, and it's same for worst and best case, because in every case we are just dividing the array into two halves, so it remains the same. Even if the array is sorted, still we'll keep on dividing it and then we merge it, so the complexity remains same. The space complexity for worst case and best case both is O of n. Why is that so? Because we would be saving these arrays into smaller arrays, and when we are merging them, we would be needing the extra space of converting the array into the sorted array. So that is why we use n. At max we'll be using the array space which is equal to the entire array. So that is how the space complexity becomes O of n. Now what we talked about was that we are using this formula, low plus high upon 2, for calculating the limit. This does gives us the right answer, but in some cases this might give us incorrect answer or an error, because in case, for example, the maximum int value of Java in Java is 2 raised to power 31 minus 1, which is approximately equal to this value. Now if we choose the array is too long and we are performing merge sort on it, so at some point we might have values like this, and if we add them, the value for low plus high would be equal to this, which actually would not fit into an int variable in Java, which means it will throw an error. So to fix this, the correct way in which we calculate the mid point is we do low plus high minus low upon 2. This, if you calculate, it would again be equal to this only. So it would be like 2 low plus high minus low upon 2, which would again be low plus high minus 2 only. But the way we calculate it programmatically, it does not give us any error. So this is how it would be. This would be subtracted, so and then it would be added to low, which would make it a smaller number than the int, and that is why it would be fitting into the integer value of Java, and that is why we use this formula. So anytime you go in interview and you calculate the midpoint, always use this formula and explain to the interviewer why you are using this formula for calculating the midpoint. So now let's move to the code. So here we have a sorting function From the sorting function, let's call a divide function, and in the divide function we need to pass the input array, a first variable and a last variable. So we would be writing another function, public static void divide, which would be expecting an input array, a first index and a last index. And here first and last would be so first would be equal to 0 because we start from the start, and last is equal to 1 to the length of the input array minus 1. That is from where we are going to start it. And let's move to the divide function. In the divide function, we basically have to look for the middle element. Middle element would be first plus last minus first upon 2, and then we need to further divide the array based on the same array, and we pass here first till mid. This would be first till mid, and then we divide the other array also from mid plus 1 to the last. And finally, when we would have all of this working, then we also have to merge the two arrays and sort them. So you can call it merge, or maybe we can call it conquer. We have to conquer the same array, and we need to pass all the elements. We need the first element, we need the mid element, and we need the last index also. So we would also be creating a conquer function here. This would again be a void function which expects an input array for start, first and mid and in last. These would be the three functions. Now let's have a look at the divide function first. Since it's a recursion, as I already said, whenever there is a recursion, there is always a base condition which ends the recursion. So in this case, our base condition would be if first becomes greater than or equal to last, that is our array reaches a single element. When our array has reached the single element, we don't need to divide it any further. So that is when our this divide recursion ends. Now let's move to the conquer method. What do we do in the conquer method? We have to sort two arrays. So we have two sub arrays, and we identify those arrays with these first, mid and last variables, and based on that we create one final array which is equal to these or which is equal to all the elements of these two arrays, and also it is sorted. So let's create two new arrays. So what we'll be doing is we have one single array and we have references of three variables which define different position of the arrays based on which we have partitioned the array. So we'll take two new arrays, we'll fill both the left part and the right part in those two arrays, and then we'll replace the input array with the sorted values so that the final array is sorted in place. We don't need to return anything. So let's create two new arrays. This would be the length of the first array, which would be mid minus first plus 1. Why would it be? First array is from first till mid, so the number of elements inside that array would be mid minus first plus 1 because it's 0th index. So when we are talking about length, we'll do plus 1. And for the second array, it would be last minus mid. So we'll create two new arrays. And now we fill these arrays with the values from the input array. We do first plus I over here is because our in original array can be actually referred from any position. So if we are referring from somewhere in between the length of the input array, so in order to move, and we only have the first pointer for knowing the position, so for knowing the next pointer we would do first plus I first, and I would range from 0 to n1, so it would be first plus 0, first plus 1, first plus 2. That is how we'll be accessing all of the consecutive elements. And similarly we'll be filling the right array as well. So here we are doing mid plus 1 plus j, because for the second part of the array we are starting from mid plus 1. The mid element is something that we have counted in the first array, in the left array. So the right array actually starts from mid plus 1, and from mid plus 1 we add j, so it becomes mid plus 1 plus 0, mid plus 1 plus 2, and so on. Now that is, here we have created two more sub arrays. Now we'll be creating the final sorted array. So we take 3 pointers, ptr1, ptr2, and ptr. Ptr1 would start from 0, as ptr1 would be pointed to the left array, ptr2 would be pointed to the right array. Both of these would start from 0, and we'll have another third variable which would be for referring the original input array, and that would start from first, because first is input array starting from first till last. So ptr that would be referring to the original array would start from first. Now we start a while loop. What this while loop will do is it will compare the element from the left array and the right array, and it will see whichever one is smaller, it will put it in the original array. Now till when this loop would run, till ptr, the pointer of the left array, is smaller than n1, that was the length of the left array, and ptr2 is less than n2, which was the length of the right array. So till any of these pointers is smaller than the length of those arrays, the while loop would run. Now the condition, if left of ptr1 is greater than right, so what we do is we would be putting the smaller element in the original array. So smaller element is right, so we put right ptr2, and since we have put the right element, we would be incrementing the ptr2 pointer. And if that is not the case, that means we have run into the else case, so the left element is smaller. So in that case we'll be putting the left element from the left array, and in that case we'll be incrementing ptr plus ptr1. And in both the cases we anyways have to increment the pointer for the original array, because in every iteration we are adding one element to the original array, whether from the left or from the right. So anyway, this has to be added. Now there can be, we would reach a position, because both of these arrays are sorted. When we are merging them, they are sorted. So it can happen that we have consumed all of the elements of one array and the other array is left. So in that case, we don't need to compare it. We just need to add all the elements one by one. We just need to push the elements all together to the original array. So we'll not have, we can skip this part. So that is for that we'll be writing the code as while ptr1 is less than n1. So we start the loop. We simply do input of would be a left one, and we increment and similarly for the second pointer. So that is all, and we have these two loops because at one point of time only one of this will work. Both of these cannot work at once, because either the first array would be consumed or the second array would be consumed. If the first array is already consumed and the second one is left, then this loop would run, and vice versa for the other case. So that is all we had to do for the code. Now just let's run the code and see the result. So we had this array, and after sorting, this is the array that we have got. So our code is working. We are able to sort the array using MergeSort, and that was it. I hope you got to learn something from today's video. That's all for today's video. Thank you so much.